Today I'm going to talk about placement in a distribution. So, to recall, a distribution is basically how often all the various possible results can happen when measuring something specific. For example, the distribution of grades might be, I could list all the various grades and how often each one was gotten. That would be the distribution. And we usually describe them, we usually show people things about them, either by quoting specific things about the distribution, like the minimum was this and the maximum was this and the average was this, or by drawing a graph, say a histogram or a dot plot, to show what the data is. Right now we're going to be dealing with numeric distributions rather than categorical distributions. There won't be like, what's your favorite food, 5 different possible answers. This is going to be number results. What's a more impressive test grade? Getting a 75 or getting an 80? On the surface, you would say 80, but it depends on the distribution that it's part of. If the class average is 10 points lower, that's more impressive relative to everything else than an 80 is compared to a 75, right? Because you're 10 points above the average instead of 5 points above the average, right? So context matters, right? And comparing to the average is one way, but this is still, at first everybody was saying 80, now everybody's going to be saying, oh, 75 is more impressive. But we still are missing a key piece here. If I want to know where a person stands relative to their peers, or where a specific result stands relative to the other results, like my income is X above average, below average, whatever, how is it? I will try to compare it to everything else that, every other point in that distribution. And at first it seemed, the class average here is 65, the class average here is 75, so 10 points above the average is much more impressive than 5 points above the average. But then you get to see that everybody here got almost exactly the same grade, and so 80 really stands out as significantly higher, while over here, 75 doesn't stand out at all. So, we're going to find two ways to measure location in a distribution. One of them is a very simple way, percentiles, and the other way is more complicated, z-score. So on one hand, oops, maybe I shouldn't write all this yet. Percentile will just be what percentage is below this result. What percentage of the results are below this? Very often, colloquially and quickly, percent to the left being usually less on a number line. Or on a histogram. But then z-score will be more involved. It'll be how many standard deviations above or below the mean are we? I'll show how this is calculated. Let's start with the percentile. What percentile is this result? Well, 75 is above 1, 2, 3, 4, 5 results out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 results. So it is above 5 out of the 9 data points. That gives it a percentile of this, which basically is 55.5, fifth percentile. Usually people just round it to the nearest percentile and say it's the 56th percentile. Over here, this is higher than 1, 2, 3, 4, 5, 6, 7, 8 out of 9. 8 out of 9 is 0.888. So that would be the 89th percentile. If any of you got really, really high SAT scores, you would have noticed that it says you're in the 99th percentile, not the 100th percentile. It's because there is no point that is above 100% of all the points, because you have to include itself. There is a 0th percentile, but there's no 100th percentile. That makes sense because you wouldn't want 101 different percentiles. You'd want 100 percentiles. If you have 0th percentile, you have to have the other end be the 99th. So yeah, in these distributions with very few data points, you can't be higher than the 89th percentile. That's just how it goes. But percentile is useful-ish, but it's also very simplistic. It doesn't tell you, like, this person is not only in the 89th percentile, this person's also very exceptional compared to everybody else. Everybody else is right around 74, 75, and this person really stands out. 90, these are all spread out, so 90 maybe doesn't stand out quite so much. If this was 85, well, let's not get into it. This could be a 76 and wouldn't stand out so much. This could be 80 and it stands out a lot more. So there's a different method which is more commonly used to measure where a specific person is in a distribution. And that is z-score. So let's talk about that. The average here in this group was 65. This person got a 75, so that's 10 points above the average. But these points are all very spread out. The standard deviation is 18.3. So we don't measure in how many points above the average, because, imagine if this person writes all their numbers as decimals, 0.75, 0.75, 0.8, like, that suddenly, the raw number of difference doesn't matter so much as how many standard deviations, how many typical differences from the mean it is above the average. So the z-score of this point is probably about 0.5, 0.6. This person is half a standard deviation above the mean. There's an average, 65, and then typically people are spread out some distance from 65. This person isn't particularly much above or below 65. They have a positive z-score of about, it's about 0.6. So this person is somewhat above average, but not even as far from the mean as is typical for points to be. Points are typically 18.3 away from the mean, and this person is closer than that to the mean, not exceptional. Above average, but not exceptional. That's what the z-score is going to say. Whereas over here, the standard deviation here is exactly 2, and over here, the person is 5 points above the mean, and a standard deviation is 2, so this person is 2.5 standard deviations above the mean. A typical person is 1 standard deviation above or below the mean. This person is not only above the mean, they are 2.5 standard deviations above the mean. They are exceptionally good. And that's why z-score is so, it's a comprehensive measure of where a point is relative to everything else. It takes into account a bit of how spread out they are, and takes into account how far above or below they are. There's a formula for z-score, which you will see a lot of. It's used in a lot of contexts. So you take an individual point, x or xi for like x3, x1, x whatever, one of the data points, and you compare it against the average. And sometimes you're going to see mu used instead, the Greek letter. And you compare that with the standard deviation. Let me write this with Greek letters. You'll see it more often in that format. This is the formula for z-score. You take your individual point you want to measure, you subtract the average from it, and then you divide it by the standard deviation. That's what I did in both of these cases, without writing out the formula, obviously. The point over here was 75, subtract the average, which is 65, and then divide by the standard deviation. relative measure of a location in a distribution. Both of these, both percentile and z-score can be used in, to calculate a point's position in a quantitative distribution pretty much any time in any situation.